Okay, there's some more basics of internal combustion engine operation I wanted to go over with you so you have a better picture of what's happening in the video. We've mentioned a 4-cycle gasoline Otto cycle before, a low compression engine. Now, there's four parts to a 4-cycle cycle. And we're going to start with them here. We're going to show you. Here's the piston, and this is in the cylinder. Here's a crankshaft. Here's the piston rod coming down from the piston. And here's the top of the piston. Here's one valve. Here's another valve. And as Roy was showing, in a standard vehicle, you'll have a throttle plate here. In a multi-fuel injection vehicle, you'll have gasoline fuel injection coming right here. Now the first part of the cycle, I should draw a little bigger. First part of the cycle is the piston is up here near top dead center, and it's going to be going down. Now what this is going to do, it's going to draw in air like this, and at the same time fuel is going to be misted in from the injector, both of which go into the top of the cylinder where the piston is. The piston is pulling down. Let me draw a little bigger over here. So anyways, the piston is here, and she is on her way down to the bottom. Downward stroke. Fuel and air are rushing in like this and filling up this space here. Now, this is going to reach the bottom, down here, bottom dead center. And what you're going to have the piston down here, and at the bottom of the cylinder, here's the intake valve, here's the outtake valve. These, of course, they have they close. And that's where the cam comes in, allowing these to open or close. The cam is really the computer program, the mechanical computer program for the engine, how it runs. So the cam opens up, lets the fuel and air in. Then we go to bottom dead center, and this is all full of fuel and air in here. Fuel to air ratio might be 13, 14 to 1, depending on where it's an old engine, new engine, what the altitude is and everything. So anyways, this is going to start going up like this. And we have a spark plug sitting right here too. So this is the intake. This is the intake stroke. Now we're going to begin what's called the compression stroke. And this is the piston is going to move up. And what it's going to do, it's going to compress this air to fuel ratio. These are closed up here, okay? The piston is squishing the fuel and the air, compressing it. So then what happens is the piston reaches someplace up here near top dead center, as we've been talking about in the video. And it has compressed the fuel and air. This is where what's called a compression ratio comes in an engine. So it gets, and the gasoline engine is going to get near the top on the way, so many degrees before top dead center. In our hydrogen engines we're talking about detonating right here at top dead center, as squished as it can possibly get before it detonates. So we get up here to the top, fully compressed, spark plug right here, fuel and air in here, spark plug ignites. Or spark plug causes ignition. So the spark plug discharges, causes ignition, and it ignites this fuel air mixture. Now, if you were to look at this in slow motion, let me see how best to draw this. We're going to exaggerate a little bit here. We're going to, let's exaggerate a lot. Let's blow this thing up. So here we are with a fuel-air ratio mixture. It ignites and it begins to propagate out this way. But see, at the meantime, during this compression stroke up here, the fuel has already coated the wall. It's coated the top of the cylinder, and it's coated this wall over here along with the oil. So what we have is we have this slower outward combustion of fuel and air, and it travels, there's a little bit of space, and it also has to try to ignite and burn the fuel that's on top of the piston, on the side of the wall, on the side of the wall. And this is with a gasoline-fueled engine. So anyways, obviously the combustion of fuel and air makes a great deal of high pressure. So then we start what's called the power stroke. And it begins to push the piston down. Okay? This is where the piston is connected to the rod. It's connected to the crank, part of the crank down here. This is what gives your vehicle its power. It is pushing back down against this. This is rotating this way, back like this. This is what causes the shaft of the engine to turn, which goes to the transmission, which goes to the prop shaft, or the rear drive shaft, which goes to the axle, which goes to the wheel, which makes contact with the pavement, which moves you down the road. It's this cycle right here, this part, this power stroke, that is giving you your motive force to go down the road. And remember, this is just one out of 4 parts of the cycle. So anyways, we're going to get all the way down to the bottom, at the bottom of the power stroke. We've reached the bottom, and now we're full of exhaust gas products in here. Now, if this was an ideal world and everything burnt perfectly with gasoline and air, your byproducts of combustion, well, anyways, your byproducts of combustion minus emissions or pollutants is going to be CO2, carbon dioxide, and water vapor. Now, you're going to have some fractionated hydrocarbons in there, also called VOCs, some methanes, and you won't have perfect combination with the oxygen, so you'll have some carbon monoxides. These are pretty low in today's world. We do an excellent job in modern automobiles, cars, gasoline-fueled vehicles on emissions. But the majority of your emissions are right here. Carbon dioxide and water vapor. So we're at the bottom of the power stroke. Now we begin what's called the exhaust stroke. And the exhaust stroke is going to be this going up. The difference is, instead of the intake valve being open to let air and fuel in, the exhaust valve is going to be open, and this is going to be closed, and you're going to be sending these byproducts of combustion out into the exhaust. Well, they'll go through the pre-cat, the catalytic converter, the muffler, tailpipe, and then out to the atmosphere. So over here, we're going to show the piston coming up near top dead center. This is closed. That's a spark plug. This is open. So the byproducts of combustion are being forced out. Sorry about that. Don't yell at me. I'm centered down. So the byproducts of combustion are going to be going out. This, of course, goes, most vehicles today have a pre-catalytic converter. Why? Because this is hot here, and this heats up the catalytic converter quicker and reduces what's called startup emissions. The majority of any vehicle's emissions happen in the first minute of its idling, of its running, which is what in the first minute, and that will be more emissions than the vehicle will do all day. So they put pre-cats coupled closer to the engine, and they're actually trying to build them into the manifold now. So it goes through your pre-cat, then it goes under the body of the vehicle. It'll go through the catalytic converter, and it'll go through the muffler. And if you want to sound really cool, i.e. obnoxious, you might have a resonator, which is only to make it go and piss off everyone in the neighborhood, trying to make your little 4-cylinder wah-wah engine sound like a big muscle car. Then through the tailpipe, and then out into the exhaust. So that's a 4-cycle engine. You suck the air and fuel in as it's going down, and then it's in here, the fuel and the air. Then you start the compression stroke, which compresses the fuel in the air. You get all nice and compressed, and you ignite it, and it goes bang. When it goes bang, you get the propagation of the flame of the fuel and air going through the cylinder, pushing the piston down, and it's burning what's in here, and it's also trying to scrub and get what's off the top of the cylinder and the sidewalls. Keep this in mind, because this is one of the things that makes hydrogen so efficient. So here we are on our power stroke, our downstroke, and this again is what's putting the motive force into the shaft, into your crank, which is into the shaft of the engine, which turns the wheels. Well, it turns the transmission, turns the axle, turns the rear differential, turns the wheels, blah, blah, blah. So anyways, we're at the bottom of the power stroke. We're filled full of carbon dioxide, water, vapor, and our minor emissions in here. And we begin the exhaust stroke. The exhaust stroke is going to go up, as I mentioned over here, up. It's going to go up, and it's going to push the exhaust byproducts out the exhaust valve with the intake valve closed, of course. And it's going to go through the pre-cat, through the catalytic converter, through the muffler, and through the I am not cool resonator, and out. Now, one cool thing is these catalytic converters. Oh boy, they do a lot of things. One, this is underneath the hood, this pre-cat. It adds a lot of thermal heat underneath the hood, which is something we don't want. It's a real pain in the rear end in designing a car, having all this heat under the hood. These catalytic converters here have precious metal in them, generally platinum, and a variety of other rare earth elements. And these are expensive. In fact, you can take an old catalytic converter. You used to be able to take them to the junkyard and get like 10 bucks for them. And they'd recover $20, $30 worth of precious metal out of them. So one of the things is when you're burning with hydrogen, as Roy has covered and we will cover, you don't get hydrogen. Hydrogen isn't coating the top of the cylinder, it's not coating the sidewalls, and it burns very quickly, 8 to 10 times faster than this. So you're not losing your fuel here, and here, and here, and plus you're running unthrottled, which Roy covers, and your byproduct coming out is going to be H2O. You get H2 plus O2 is going to yield, well, it's going to be H2 plus O. It's going to yield H2O, water vapor. Now, even if you're burning methane and hydrogen, because we talk about multi-fuel in this DVD, CH4 plus O2 yields CO2, carbon dioxide plus water vapor. So your hydrogen is also in there, it's H2 plus O, yielding H2O. So if you get your emissions down to water vapor, basically one of the really great things you can do is you're running cooler, you can get rid of this heat underneath the hood, which simplifies the design, simplifies the manufacturing, reduces the heat shield costs, and that's a lot of money in some cars. You get rid of your platinum catalyst here, you get rid of your platinum catalyst there, you save all this money, and believe me, in the automobile industry, they'll make you vice president if you can save $50 per vehicle. So that is some of the basics of a 4-cycle engine cycle, as I wanted to explain it to you. Really go over it in a little bit more detail than that was on the whiteboard for those of you who are new to this field.